Chinese ancient mathematics had its own line of development, its own method of thinking, and even its own style of presentation. It is not only independent of, but even quite different from the Western mathematics as descendants of Greeks. Chinese mathematics was defined by the Chinese in ancient times as the art of calculation, or Suan Chu. This art was both a practical and spiritual one, which covered a wide range of subjects from religion and astronomy to water control and administration. The history of China is filled with many periods marked by flourishing culture and civilization, and others marked by competition and war between dynasties and invaders. By the year 1000 AD, the Chinese had invented seismographs to measure earthquakes. The Chinese also had ships big enough to sail around the world, but did not do so, and compasses with a magnetic needle used for navigation in 1119. China had developed many other inventions in science and technology, including gunpowder, paper money, movable type, and blast furnaces capable of producing cast iron. Among China's books were the new and more detailed pharmacopoeia of the Kaipao reign period. The first true evidence of mathematical activity in China can be found in numeration symbols on tortoise shells and flat cattle bones, commonly called oracle bones, dated from the Shang dynasty in the 14th century BC. These numerical inscriptions contain both tally and code symbols, which are based on a decimal system, and they employed a positional value system. This proves that the Chinese were one of the first civilizations to understand and efficiently use a decimal numeration system. Early Chinese mathematics had a great influence on other later civilizations in India, Japan, Korea, and other counties. Ancient Chinese made all computations in manipulating rods and counting boards. This was possible because the Chinese already possessed, in very remote times, the most perfect place value decimal system. It allowed them to represent the integers by properly arranged rods placed in due positions on the board. In fact, the word arithmetic, the usual terminology for mathematics, was just a literal translation of Chinese characters Suan Shui, meaning counting methods. On integers, in ancient Chinese mathematics, there were no notions of prime number and factorization or its likeness. However, there was a mutual subtraction algorithm for finding the GCD of two integers. Its name literally meant equal. On geometry, geometry was intensely studied, in addition to being well developed in ancient China. The misunderstanding is likely due to the fact that Chinese ancient geometry was of a type quite different from that of Euclid, both in content and presentation. Thus, the Chinese ancestors paid no attention at all to the parallelism, but on the contrary, showed great interest in orthogonality of lines. On algebra, algebra was no doubt the most developed part of mathematics in ancient China. It should be pointed out that algebra at that time was actually a synonym for method of equation solving. Shang numerals. The numeration system used in the modern world had its origins 34 centuries ago in Shang, China. However, mathematics in China began much earlier in the development of the Chinese calendar, flood control measures, administration, and so on. The need to control the flood-prone rivers of China, such as the Yangtze and the Yellow Rivers, was an important factor in the development of mathematics in ancient China. The legend of Lo Shu. According to a legend, a mythological emperor Yu received a divine gift from a Lo River tortoise. The gift was in the form of diagrams called Lo Shu, which was believed to contain the principles of Chinese mathematics. One diagram, the magic square, was thought to possess magical qualities and led to the development of the dualistic theory of yin and yang, where yin represents even numbers 2, 4, 6, 8, 10, and yang represents odd numbers 1, 3, 5, 7, 9, 11.
Tangrams and other aids were also invented in China during the Zhou dynasty. In addition, over the 1,000 years of mathematical progress, the Chinese have invented a large variety and countless numbers of mathematical puzzles and games. Chinese counting boards. By the time of the Han dynasty, which is during the 2nd century BC to 4th century AD, the Shang numerals were developed into a system, used on a counting board and a set of counting rods known as chosuan. Indeed, the evolution and development of counting rod numerals continued for about 3,000 years in China. The abacus is perhaps the best known counting board, but it was only developed around the 15th century. Counting boards were divided into columns designating positional groupings of 10. 0 was indicated by a blank space on the counting board, and negative numbers were also used in mathematical calculations. 2 types of rods were used, red and black or positive and negative, representing yin and yang. The use of the abacus is often thought of as a Chinese idea, although some type of abacus was in use in Mesopotamia, Egypt, and Greece. Probably much earlier than in China, which was during the first Chinese abacus or Xuanpan. We know of the dates to about the 2nd century BCE. Chinese math texts. The history of Chinese mathematics and mathematicians were mostly lost or destroyed over the centuries. For example, the despotic Emperor Shi Huangdi of the Qin dynasty, that's 221 to 207 BC, ordered the burning of books in 213 BC. Scholars in the following Han period, 206 BC to 220 AD, had to transcribe China's literary and scientific traditions from memory or remaining fragments of scroll. Since the 16th century, Chinese math history has also been denied and ignored in the Western dominance of science and technology, both inside and outside China. These texts prove that the Chinese were the first society to use some of the most basic and advanced mathematical principles and concepts utilized in modern times. 2 of these texts are the Chao Pei and Qiu Chang. Chao Pei. It is the oldest existing Chinese text containing formal mathematical theories that were produced during the Han period. The arithmetic classic of the gnomon and the circular paths of heaven, or the Chao Pei Xuanqing, dated before the 3rd century BC, which contains various modern mathematical principles such as working with fractions and using a common denominator, and proofs of many geometrical theories. The text contains an accurate process of division for finding out the square root of numbers. In fact, the Chao Pei presents the oldest known proof of the right-angle triangle theory in the Xuan-Tu diagram. This theory, commonly known as the Pythagorean theorem, shows that the sum of the squares of the legs of a right triangle is equal to the squares of the hypotenuse, or a squared plus b squared equals c squared. The principles in the text were reflected in the popular approach known as Chi Chu, or piling up of squares, which was a process of using geometry to solve algebraic problems. The Qiu Chang. Another 3rd century BC Han text, the 9 chapters on the mathematical art, or the Qiu Chang Xuan Shu, was very influential in Asian mathematics. The Qiu Chang focuses on applied mathematics in engineering and administration, and include 9 distinct chapters on impartial taxation, or the Chun Shu, engineering works, or the Shang Kong, and the surveying of the land, or the Fang Tian, and etc. Other important Chinese math texts include the mathematical classic of Sun Tzu, or the Sun Tzu Xuanqing, written in the 3rd century AD, and the 10 mathematical manuals, or the Xuanjing Shishu. The 13th century text, detailed analysis of the mathematical rules in the 9 chapters, or the Xiang Jie Qiu Chang Xuan Fa, proved the theory known as Pascal's triangle 300 years before Pascal was born. The ancient number system. Even as mathematical developments in the ancient Greek world were beginning to falter during the final centuries BCE, the burgeoning trade empire of China was leading Chinese mathematics to ever greater heights. The simple but efficient ancient Chinese numbering system, therefore a decimal place value system, very similar to the one we use today, was the first such used number system adopted by the Chinese over 1,000 years before it was adopted in the West, and it made even quite complex calculations very quick and easy. there was a pervasive fascination with numbers and mathematical patterns in ancient China, and different numbers were believed to have cosmic significance. In particular, magic squares, squares of number where each row, column, and diagonal added up to the same total, were regarded as having great spiritual and religious significance. But the main thrust of Chinese mathematics developed in response to the empire's growing need for mathematically competent administrators. A textbook called Juxiang Xuanshu, or 9 Chapters on the Mathematical Art, written over a period of time from around 200 BCE onwards, probably by a variety of authors, became an important tool in the education of such a civil service, covering hundreds of problems in practical areas such as trade, taxation, engineering, and the payment of wages. It was particularly important as a guide to how to solve equations, the deduction of an unknown number from other known information, using a sophisticated matrix-based method which did not appear in the West until Carl Friedrich Gauss rediscovered it at the beginning of the 19th century, and which is now known as the Gaussian elimination. Among the greatest mathematicians of ancient China was Liu Hui, who produced a detailed commentary on the 9 chapters in 263 CE. By an approximation using a regular polygon with 192 sides, he also formulated an algorithm which calculated the value of pi as 3.14159, correct to 5 decimal places, as well as developing a very early form of both integral and differential calculus. They also started to pursue more abstract mathematical problems, although usually couched in rather artificial practical terms, including what has become known as the Chinese remainder theorem. This uses the remainders after dividing an unknown number by a succession of smaller numbers, such as 3, 5, and 7, in order to calculate the smallest value of the unknown number. A technique for solving such problems, initially posed by Sun Tzu in the 3rd century CE, was being used to measure planetary movements by Chinese astronomers in the 6th century AD, and even today it has practical uses, such as in internet cryptography. By the 13th century, the golden age of Chinese mathematics, there were over 30 prestigious mathematics schools scattered across China. Perhaps the most brilliant Chinese mathematician of this time was Qin Juishao, who explored solutions to quadratic and even cubic equations using a method of repeated approximations very similar to that later devised in the West by Sir Isaac Newton in the 17th century.